So we are talking about both the surface area and a volume of spheres today. Both are, I think, relatively simple. So let's start off with our vocabulary here. So the first thing, a sphere is the set of all points in space equidistant from a given point that is called the center. So it's a similar definition for the definition of a circle. So whenever we talked about circles last chapter, I told you that I never thought of a circle that way. That a circle is the set of all points equidistant from a point. Which a sphere is the same thing, but how a circle is two-dimensional, just flat. A sphere, right, would be all the way around in space, okay? But a three-dimensional space, points equidistant from the center. Okay, now, a word that you may not have heard before, I guess words technically, is a great circle. Okay. A great circle is going to be any circle that has the same center as the sphere. Now, a sphere is a three-dimensional object, but it still does have a center, point right there, equidistant from all the outside edges. A circle is a two-dimensional object, but also still has a center. So they did draw a great circle here. So if you were to look at this circle here, its center is the center of the sphere. Now that's not the only great circle on this picture. You could draw one maybe like right here. As long as the center, I know it doesn't really look like a circle because it's in three-dimensional space, right? But that circle would have the center as the sphere. And, right, you could go all the way over here. Now, to kind of show you what wouldn't be a great circle. If I had a circle that was like up here somewhere, the center of that circle, that two-dimensional circle, is here. See the difference? Okay, so what a great circle does, yes, it has a center the same as the sphere, but even more importantly, it divides the sphere into two equal hemispheres. So it's basically going to cut the sphere in half. Okay, so our formulas for surface area and volume. Starting here with surface area. As I was going through making your guys' notes yesterday, I really liked how they explained surface area of a sphere. They had a really good visual in your book. If you're interested, you can look in there. But they had a baseball. And if we're talking about I know this is a softball, but okay, baseball. Same idea, right? Okay. So the surface area would be, right, like how much paint it would take to cover. It's basically, right, like the yellow part, right? If you were to lay it flat on this yellow part. Well, what happens if you look at the outside of this ball, that right there is a circle, that right there is a circle, that right there is a circle, and that right there is a circle. And yeah, there's kind of these spots that kind of overlap, but it ends up working out perfectly. It's really, really kind of interesting, okay? That this circle and this circle and this, all four of those circles, they're the same. And if you found the area, and there's four of them, the surface area is 4 pi r squared. So that was kind of a good visual way of thinking about surface area of the sphere. And then we have volume of the sphere. That is going to be 4/3 pi r cubed. So 2 new formulas today. So let's practice with these 2 formulas. Let's start by finding the surface area and the volume of the sphere. So for surface area, everything about that baseball, there are 4 congruent circles. So to find the area of the circle, we take pi r squared. So to find the surface area, right, of 4 of them, it would be 4 pi r. What is my radius? 5 squared. Now if I want to write this in terms of pi, 5 times 5 is 25. Times 4 would be 100 pi meters squared. Surface area, right? Area is always squared. And then to find volume, the formula for volume is 4/3 pi r cubed. So 4/3 times pi times 5 cubed. So leave it in terms of pi if you wanted to do 5 cubed, which is 125 times 4/3, you're going to be getting like 500 over 3 or something like that. Anyway, let's just turn it to a decimal. It'll just be simpler to talk about it that way, which would end up being about 166.7 pi meters cubed, right? Volume, meters cubed. We'll do a little bit today of leaving things in terms of pi and then estimating to the nearest whole number. But that's spheres. Okay? Let's get this glued into page 61, 11.6 surface area and volume of spheres. All right, so let's start with surface area. We will leave our answer in terms of pi. All right, number 1. Let's say we have a sphere that has a radius of 10 inches. All right, so surface area. To find the surface area of a sphere, the surface area is that 4 pi r squared. So in this case, 4 times pi. They give me the radius. It is 10. So you do 10 squared. If you're doing it in multiple steps, make sure you do the exponents first. 10 squared, 10 times 10 times 4 would be 400 pi inches squared. Now, number 2. What if I have a diameter of 6 1/10 meters? Okay, to find the surface area, we need 4 pi r squared, so I need the radius. So, I had that second hour kind of freak out a little bit. Okay, a couple of options here. To find the radius, I need to divide that by 2. 6 divided by 2, 3. But then I also have to take that 1/10, and I need to find half of that. Right, you have 6 wholes and then 1/10, so I found half of the 6. So half of the 1/10, instead of taking 1/10 divided by 2, what's another way to think of divide by 2? Multiply by 1/2, which would give me 1/20. So half of 6 1/10 would be 3 1/20. That's one option. Or you could do a decimal, right? So 6 1/10 would be 6.1. Divide that by 2, 3.05. I don't really care. If you're more comfortable with decimals, use decimals. Either way, to find the surface area, we take 4 pi. Let's go ahead and let's use the decimals here. So we're going to take 3.05 squared. Excuse me. Which would end up getting me 37.21 pi meters squared. Okay, surface area, not too bad. Questions on those two? Okay, so spheres and the formulas for spheres, I think are relatively simple because you're just looking for the radius. So what we're going to do next is we are going to, instead of giving you the radius or giving you the diameter, we have a sphere with the given circumference. I want to find the surface area. So let's say I have a sphere that has a circumference of 15 inches. Okay, I am looking for the surface area. Now, to find the surface area, I need 4 pi r squared. I need the radius. And they don't give me the radius, they give me the circumference. But how do you find the circumference? With the radius. How specifically with the radius? 2 pi r. That's how you find circumference. So when I take 2 pi r, I get 15. So what I'm trying to do is I'm trying to solve for r. So to get rid of the 2 pi, I would divide by 2 pi. Now, you need to be really careful here because in your calculator, if you take 15 divided by 2 pi like this, it's not going to give you the right answer. Because I need to take 15 divided by 2 pi, right? Okay, your calculator is going to take 15 divided by 2, multiply that by pi. That's not what I want to do, right? So, in your calculator, either find out what 2 pi is and then 15 divided by that, or put 2 pi in parentheses. Either way, we should end up with a radius of 2.39-ish. You're going to have to round there. Okay, well, once I have the radius, I'm looking for the surface area. So to find surface area for pi r squared. 4 pi r squared. So for this one, it says round to the nearest whole number. It should end up being about 72 inches squared. So some of what you have to do today is find the radius first and then use that for your other formula. Questions on that one? Okay, let's move on to volume. So for these ones, we will find volume in terms of pi, and then we'll go ahead and estimate and round to the nearest cubic units. So number 4, let's draw a sphere in a great circle. Now this sphere is going to have a radius of 6 inches. So this one's pretty straightforward. The formula for volume of a sphere. The formula for volume of a sphere is 4/3 pi r cubed. So we're going to do 4/3 pi. My radius is 6 cubed. Now, if you have a calculator that you can't plug it in like all big one thing, we want to find it in terms of pi, so you really are just going to take 4/3 times 6 cubed. If you have to do your operations one at a time, you're going to need to make sure you 6 cubed first, and then multiply by 4/3. You should get 288 pi inches cubed in terms of pi. And then if I want to round that to the nearest cubic inch to estimate, 288 times pi gives me about 905 inches cubed. Okay, number 5, let's try one more volume of a sphere. Alright, so this time, all the way across the sphere is going to be 12.6 centimeters. Okay, the volume is 4/3 pi r cubed. So I need the radius. If the diameter all the way across is 12.6, what is my radius? 6.3. So we will take 6.3 cubed. Once again, order of operations is always the thing, so you need to make sure you cube it first, then multiply by 4/3. This one we are going to have to round a little bit. We should get about 334 pi centimeters cubed if we were going to leave it in terms of pi. And then round it to the nearest cubic centimeter. Evaluating with pi, we should get about 1,049 centimeters cubed. Depending on how and when you round, your answers may be off by a number or two. I had somebody last class on 1047. As long as you're close. Okay, now this last one is going to be kind of like number 3. So this last one, we're going to have a sphere with this given volume. I want to then turn around and find the surface area. Okay, so let's say we have a sphere that has a volume of 140 centimeters cubed. So similar to the circumference one, my goal is to find surface area. To find the surface area, I have to have the radius. And they don't give me the radius, they give me the volume. But where did that volume come from? Can you find the volume? 4/3 pi r cubed. When I took 4/3 times pi times the radius, which I'm looking for, and I cubed it, I got 140. So what I need is I need to solve for r, which means I'm first going to need to solve for r cubed. You don't have to do this in 2 steps, but I almost think it might be simpler to do it in 2 steps. If you wanted to, you could divide both sides by 4/3 pi, but that gets kind of funny since it's a fraction. So instead, if we start by getting rid of the 4/3, to get rid of the 4/3, we could multiply both sides by 3/4. That would get rid of my 4/3. So I'd have pi r cubed 140 times 3/4 gives me 105. Remember, I'm solving for r, and pi is not a variable. I think we oftentimes think of it as a variable because it's a symbol, but it's a number, right? So I can divide both sides by that number. I can divide both sides by pi, and we get r cubed equals 105 divided by pi gives you about 33.4. But now what I need to do is I need to solve for r, and so I have r cubed. We have done a lot of examples with Pythagorean theorem and other things where I had to get rid of the square. Like if I had x squared equals 16, square root both sides, we'd get our answer. So if I'm trying to get rid of the squared, I square root it. But this is a cube. Cube root. Yeah, you cube root. What that looks like, it looks like this. So a square root means what number times itself gives me that number. A cube root means what number multiplied by itself 3 times gives me that number. So we cube root the left, we cube root the right. Okay, so on your calculators, because I want you guys to practice this. So the one, Brianna, why don't you hold up your calculator? Most of you probably have this one, okay? If you don't, I can help you find the button you're looking for. But the button you're looking for looks like the square root symbol with a little X on it. Okay? You're going to probably have to hit the second key to get to it. But before you do that, okay, what this is saying is you want to take the x root of something. So you have to tell your calculator, do you want to take the 3rd root, the 4th root, the 5th root? You have to write that number first. So if I want the 3rd root, I'm going to type in 3, then I'm going to insert this symbol. Your calculator will say, okay, we're taking the, and it's going to plug that 3 in right there. We want to take the 3rd root of 33.4. I want you guys to practice doing this. Make sure you can get the answer. You should get 3.2, about 3.2. If you have a different kind of calculator, I can help you find the key group here once we finish this example. But for the one that most of you probably have, it would look like you should get 3.2. This is what you're plugging your calculator. Okay, so all that work, I found the radius. I'm looking for the surface area. So to finish this out, we would take 4 pi r squared. So 4 pi times 3.2 squared, which should give me about 129 centimeters squared.